Hello everyone, welcome to GChem classes. So today we are going to discuss Borane Chemistry. So today's class is for IIT-JAM, right? So I'll write it down what all today I'm going to discuss it with you, right? So today is for IIT-JAM and what all I'm going to discuss it with you. It's Borane. Okay. Under this Borane, we will discuss its geometry. Okay, we will discuss it cage electron. Okay, then isolable. Okay, and then finally weight. Okay, these many things I am going to discuss it, and then I'll take some previous year QIQ previous year questions also, which it's already asked in IIT-JAM exam. Correct. So like last class I have taken for aromaticity, right? So whatever I have given you the concept, that much is enough, and then you can solve any questions regarding aromaticity, right? So today I am going to deal with the Borane chemistry, and with this whatever the case electron or geometry or isolable or weight soluble, whatever they are going to ask it will be completed, right? There won't be any whatever concept is behind this, you will get everything, and then based on that you will give proper solution, okay, in your examination. Let's see, in Borane some formulas are there. Let me discuss you with the formulas. If suppose it will be better if I'll discuss with the examples, but before that I'll write down the formulas. Okay, if it is Bn, then Hn, and if it is 2 minus here, this we can write it down with this way also, Bn Hn plus 2, then it will be closo, correct? If suppose it is Bn Hn 4 minus, or we can write it by Bn Hn plus 4, it will be nilo. Okay. If suppose it is Bn Hn 6 minus, or we can write it Bn Hn plus 6, it will be arachno. Correct. Again Bn Hn 8 minus, we can write it Vn Hn plus 8. This will be your hypo. Right. So this formula, okay, you do practice with these formulas, whatever questions they will ask. Okay, if they are asking that structure type of this type of Borane, what will be the structure type? So then you have to calculate it, right? Suppose if they are asking B10H12, this way they can ask, and they'll ask that what is the structure of this, right? So how you are going to tell the structure? Just you convert it, like 2 proton is extra, like B, suppose this one is BnH12, right? B10H12. So in this, what you have to do it, you just have to convert it to the BnHn. Means you have to convert it to the B10H10. Now remaining how many proton for this kind of structure, how many proton you have to lose it? 2 proton you have to lose it, right? This 2 proton you have to lose it. So if 2 proton is like leaving from the Borane, then what will be, what we are going to write it here? 2 minus. So now you see B10H10 2 minus. It means BnHn 2 minus. If it is BnHn 2 minus, then it will fall under closo, right? So this particular Borane structure is closo, correct? So likewise we will see isolable. What is the isolable? Once we will discuss all the formulas, and then we will start practicing, correct? So before rubbing it, I'll give you some questions. You just tell me whether it's a closo, nido, arachno and hypo. Okay, B5H9, okay, this is A, and then like B you have B3 and then H9, okay, then C B10 H14, this ABC, you just tell me the structure type, okay, structure type of this Borane. By the time I'll rub the board, you just answer it, okay, ABC. What should be the answer for structure? Fast. Okay, that I am not going to solve it, you are going to solve it, right? A, B and C, tell me what type of structure it will have, correct? Then I am going to the isolobal. What is isolobal? You just solve it. I am going for isolobal. See, this isolobal concept is it is like if you are going through with the molecular orbital pictures, it will take more time, right? But you have examination in 13th February, right? If you want to learn in detailed way, right? In detailed way, if you want to learn, you download my GChem classes app. Okay, it is available in Play Store, and then there you can ask it, or you can join the class if you want. Okay, if you're willing to join the classes, you can join there. Otherwise, don't waste your money. Here only I'll give you everything, right? But till then, because now it's a exam time, right? 13th February we have exam, so we have to consider some important concept. I'm not talking about important questions. I'm talking about important concept. So from where the question can arrive, right? Because if you see the pattern of last 5 years or 4 years, what they are following, even the number of like question number, what I got like 2022 and 2019, I guess, they have question number 17 fixed for Borane, right? Borane structure. So we will discuss all those things, right? So now isolable. What is isolable? See, two different compound will be given, and with that they will ask that how many structures like electrons, whether electrons are similar or not. Okay, if electrons are similar, it will be isolable. Or the frontier molecular orbital, if the frontier molecular orbitals are symmetry like equal, then also it can be isolable. If both having same symmetry, then also it is isolable. So it means for isolable, the condition should be, it should have same symmetry, it should have same similar frontier molecular orbital, it should have same electron, right? In that frontier molecular orbital, both the compounds should have same electron, same number of electron, right? Then only it can be isolable. So the symbol we are using for isolable is like this, okay? So better I'll take examples and I'll solve it. So it will be better for you. So I'm having some of the examples. Let me see. Suppose if you are taking carbon. So carbon is having how many valence electron? I'm not talking about valency. Valence electron. Here you have to talk about valence electron. So how many valence electron? 4. Okay. So this will be isolable with BH. Because boron, how many valence electron are there? 3. And hydrogen, how many valence electron are there? 1. So how many it is coming? 4. So 4 electron, here also 4 electrons. So it means carbon is isolable with BH, right? Likewise, if I'm taking nitrogen, what is the valence electron of nitrogen? It will be 5 electron, correct? And we have to search any other molecule where it is having 5 electron. We can write CH also. So here how many electrons are there? It will be 4 plus 1. So here also 5 electron. So this will be isolable with CH, and then this is also, nitrogen is also isolable with BH2. See, here valence electron is 3 and each hydrogen is having 1 valence electron. So total 1 into 2, it will be plus 2. So total here also 5 electron, here also 5 electron, here also 5 electron. So nitrogen is isolable with CH, or nitrogen is isolable with BH2, or CH is isolable with BH2. So likewise we have to find it out isolable. Even inorganic complex also, like the coordination complex also fall under this. Suppose I am taking ruthenium, this molecule, okay, forget about oxidation number and remaining whatever it is, whether it's a tetrahedral or a square planar, forget about those things. Just find it out, like what is the total number of electron here, right? Ruthenium, we have 8 electron because it is fall under that iodine family, iodine, ruthenium, osmium, right? So 8 plus each carbonyl is contributing 2 electron, right? Each carbonyl is contributing 2 electrons, so total it will be 8 electrons. So 8, 8, 16 electron, right? So this will be isolable with, I'll tell you one more thing. So 16 electron, so this will be isolable with, you have to find it out, 6 electron, right? 16 electron is isolable with 6 electrons. So here we can write BH3, or we can write NH, or we can write CH2. So this one is isolable with this one, okay, or this one, right? So I'll just write it down. What is that 16 electron and 6 electron, how it is isolable? I hope you have solved these questions. Okay, I'm not going to solve those things, it is very much easy. Okay, so here you can write it down. 4 electron is isolable with 14 electron, then 5 electron is isolable with 15 electron, 6 electron is isolable with 16 electron, 7 electron is isolable with 17 electron, and 8 electron is isolable with 18 electron. So likewise you have to calculate for this complex how many electrons is coming, and then that will be isolable with your the number you have to search it. It is very much easy. Just remove this one. Right? If you are calculating for coordination complex, just remove this one. Whatever is coming, that will be isolable with the your organic one, right? That will be isolable with your organic one. So this is the concept of isolable. So few examples here also I will give you. Let me give you first one I will solve, and then remaining you are going to solve it, right? Let's see, for isolable I am giving you some of the examples. You are going to solve it. That again I am not going to solve it, right? So I will just wait and watch. So first I will take you, this is carborane, okay, C4B2 and then H4. This is carborane. So if this type of question is arise, how you are going to solve it? Just convert it. You know that carbon is isolable with BH, right? Carbon is having 4 valence electrons, so each carbon is isolable with BH. So instead of carbon you can write BH and then make it 4, then here B2, then H4. Now what you have to do is just club it together, B2 and here it is 4. So 4 and 2, 6. So 6 boron, and hydrogen, how many hydrogen is there? Here is 4 and 4, 4, 4, 8. 8 hydrogen is there, correct? So now it is looking like B6H8. So this B6H8, just write it down, BNHN, and here it will be 2 minus because you have to lose 2 proton. So it is looking like clozo, right? It is looking like clozo, correct? So here is the role of isolable, because if carborane is given, you have to convert it. If it is nitrogen, then you have to write BH2, right? Suppose you have one more example, I will take it. No, this one you solve it, okay? C2, B10, H12. This is one question, question number 1, and question number 2. You just solve it. N2, C2, B2, H6. You have to tell me whether it's a clozo, nido, arachno, hypo. Here also clozo, nido, arachno, hypo. So this you are going to tell me now. Okay. So next topic I am going to take it is geometry for clozo. Geometry only you are going to calculate for clozo, not for arachno or nido, okay, or hypo. Because one question they have asked regarding that clozo icosahedral, okay, how many vertices are present in clozo icosahedral. So after watching this, what I am going to deal with now, it will be very much easy for you to answer whatever question they are asking in Borane chemistry, correct? Let's see, I'll just make one table, right? I'll just rub it, this one, these 2 questions already you have written, right? Now you just start answering me. Okay, start answering me. So here you have to write skeletal geometry for clozo. Okay, heading should be geometry for clozo. In that, first column will be skeletal atom, or you can write vertices, number of vertices. Okay, skeletal atom or number of vertices. Then here it will be geometry, and here example. Okay, the first will be 6. If suppose skeletal atom is 6 or vertices is 6, we all know that geometry will be octahedral. It is not going to change octahedral, right? And all the molecules should be clozo. So here it will be B6H6 2 minus. Correct? Because this is only skeletal atom or vertices. 6 is there, no? So 6 skeletal atom is there, right? Now if it is coming to the 7, then it will be PBP. What is PBP? pentagonal bipyramidal. Okay, pentagonal bipyramidal. So the example, example will be B7 H7 2 minus. Everything should be in closure format, because 2 minus I am writing, it means it is in closure structure, right? Structure should be closure, then only this will be fulfillment, otherwise it will be false, right? We can't write it for nido, we can't write it for arachno or hypo. Only you can write it for closure. So whatever question they will ask, they will just mention octahedral closure, icosahedral closure, okay, then pentagonal bipyramidal closure. So how many vertices are there in this, right? So you have to calculate like that. Pentagonal bipyramidal, you should know that it should be B7 H7. Octahedral, you should know that it should be B6 H6. Then only you can say that vertices number is 6, vertices number is 7, or skeletal atom is 6, or skeletal atom is 7, right? Likewise you have to tell. Then 8 will be dodecahedral. Okay, dodecahedral, example is very much easy. B8 H8 2 minus, right? Now next is 9. This is tricap trigonal. Okay, tricap trigonal. It will be B9 H9 2 minus. Then next will be, I guess, 10. That is bicap square antiprismatic, right? Bicap square antiprismatic. It will be B10 H10 2 minus. It is not that much difficult task. Okay, just do 2 or 3 times practices. You will get to know how many vertices are there, what is the geometry of that particularly, because same thing you are going through in your coordination complex, right? In coordination complex also, even you are going through with your chemical bonding, where the VSEPR theory is there, right? In that you are going to deal with all this geometry, correct? The same geometry we are putting to the Borane chemistry, correct? Now the next is 11, right? 11, if suppose vertices or skeletal atom is 11, then it's a decaoctahedron. Decaoctahedron. It will be B11 H11 2 minus. And the next will be 12, which already they have asked, I guess in 2019 or 2020. Okay, they have asked this question. Okay, for 12. So it will be icosahedral. Icosahedral B12 H12 2 minus. So this table will help you out for whatever the geometry type, like vertices, number of vertices, number of skeletal atom, whatever they are going to ask it, everything will be everything you can done with this. Okay, now if you want to take a screenshot, you can take it. Okay, I will be out of frame. Done. Okay, so we will moving to the next topic. Let's see Wade's rule. Okay, Wade's rule. I'll just rub the board. Okay, so I think you are enjoying now, right? So if you are enjoying, don't enjoy alone. Share this video with your friends, correct? And together you all enjoy chemistry, correct? And it is given, my WhatsApp number is given in that, you can see in that description section, my WhatsApp number is given. So please, it's my request, kindly send me WhatsApp message instead of calling, right? First you send me, if whatever problem you have, just click this photo and send it to me in WhatsApp, okay? In entire day, anytime, I'll see those questions and then I'll reply you back. Surely I'll reply you back, correct? But please, that number is given for you for your helping purpose, right? So please make use of it. Okay, so send me message, not calling. So now it's a Wade's rule. Okay, so we are to find case bonding electron, right? To finding case bonding electron, we are using this Wade's rule, correct? Again, to find framework electron and to find skeletal electron pair. Okay, this also pair you can write. See, all are similar. So in questions, they can ask in different set of name. Maybe they will ask find the cage bonding electron pair. Maybe they can ask what is the framework electron pair. For suppose one example they have given and they are asking what is the framework electron pair. Or they can ask skeletal electron pair, right? So all are similar, correct? Right? All are similar. So now I'll write one formula here. See, in skeletal electron pair or cage bonding electron, if suppose it is n plus 1, suppose it is like not like this. If suppose you are getting closo, okay, now you know how to get the closo. Suppose this example they have given B10H12. So how you are solving B10H10 2 minus. So it will be BnHn 2 minus. So you are writing that this is closo. So now you come to know that this is closo. Now next question will be that what is the case bond electron pair or framework electron pair or skeletal electron pair. Now you know the vertices also, right? So now you come to know the vertices also. You can calculate vertices, you can say the structures, okay, geometry, okay, and then now the next question is how much case bonding electron is there. So how you are going to calculate for this? If suppose it is closo, just do it 1 plus n plus 1. If it is for this question, how you will find out that the case bonding electron pair. So n plus 1, what is n? N is number of Borane, right? What is the number of Borane? 10. So here it will be 10 plus 1, so it will be 11 electron pair. Total 11 electron pair is present here in this particular structure. In this particular Borane, we have how much skeletal electron pair we have? 11 electron pair. Or number of electron, if they are asking, it will be 22 skeletal electron or 22 framework electron or 22 cage bonding electron, right? So likewise, whatever they are asking, just be thorough with your question. Okay, if you are not able to understand the question, read it again and try to imagine your this class, whatever class I am taking, try to imagine this or your notebook, then you will get to know what will be the answer, right? So now let me complete this one. So if it is closo, it will be n plus 1. If it is nido, it will be n plus 2. If it is arachno, it will be n plus 3. If it is hypo, it will be n plus 4, right? So just you have to calculate. If it is closo, the number of Borane plus 1. If it is nido, number of boron plus 2. If it is arachno, number of boron plus 3. If it is hypo, number of boron plus 4. And that many electron pair you have in that case bonding electron pair, right? In that case you have that many electron pair, right? So I think I'll give you some of the questions. You just solve it. I'll give you here only. So suppose I am giving you B2H6. This is question number 1. Then I am giving you question number 2. B2H6, then B4H10. Okay, then question number 3, I am giving you C2, B10, H12. Then I will give you question number 4, N2, C2, B4, H6, ruthenium. Okay, how many? 3 carbonyl. Okay, this question. So this is question number 4, this is question number 3, question number 1, question number 2. So in that question number 3 I am going to solve it, okay, for your reference purpose. Remaining 1, 2 and 4 you solve it, okay. Question number 2 I am solving here in board. Just see how I am solving. You just need to find out whether, 3 things you have to find out. One is whether it's a closo, nido, arachno, hypo. And first thing is structure, you have to find it out. Second, if it is closo, then what is the vertices, okay, what is the number of vertices, okay, or skeletal atom. Third thing, you have to find it out, the weight soul, that framework electron pair, okay, or skeletal electron pair, you have to find it out. So first, for question number 3 I am taking, so it is C2 B10 H12. So just convert it. C2 means it will be BH twice B10 H12, and then it will be boron, 2 boron and 10, so it will be 12 boron, and then hydrogen, how many are there? 12 plus 2, so it will be 14 So now I'm going to convert it B12, H12 and 2 minus. So it is looking like B and H and 2 minus. So it is closo. Correct? Closo. And what will be the geometry? 12 is there, 12 vertices is there, or skeletal atom. Okay, skeletal atom or vertices. How many are there? 12 are there, right? So 12 means it is icosahedral. Correct? It is icosahedral. And and how many skeletal electron pair are there? Skeletal electron pair, how you are going to calculate? If it is closo, it will be n plus 1. So n is number of boron. So 12 plus 1, it will 13 electron pair. Or number of you have to see the questions whether they have asked electron pair, skeletal electron pair, or they have asked skeletal electron. If they are asking number of skeletal electron, then it will be 13 into 2. How much? 26 electron, right? If they are asking electron pair, then 13 electron pair. So the number will be very much important in the question, because both the option will be given, 13 also and 26 also. Now you have to see the question whether they have asked electron pair or they have asked number of electron, right? So based on that you have to answer it. So likewise, like how I answer this, likewise you answer it for question number 1, question number 2. This is very much easy. And then question number 4, what you have to do it, change this nitrogen and take the isolable for boron. Here also carbon, change it to the isolable of boron. Here also ruthenium and this carbonyl, change it to the isolable of boron. And then together you just see how much it is coming, like whether it's a closo, whether it's a your nido or your arachno. Okay, whatever is coming, based on that you solve it. If it is closo, n plus 1. If it is nido, n plus 2. If it is arachno, n plus 3. If it is hypo, n plus 4. And find out the total electron pair. Okay, so we this much we have. Now I'm going to solve it your PYQ question. Okay, so for this question I'll just wait for 2 minutes and then I'll start the PYQ. Okay, it will start from 2022 and we'll go till 2019, right? So you solve this one, then we will take it direct questions. I hope you have written the question and you have started solving also. I should get the answer from you. Correct? Let's see some of the PYQs, how they have given the questions. This is from 2022. Okay, the question I am solving, it is given from 2022 IIT-JAM. Correct? So they have asked the structure type of, see the simplicity of question. Okay, very smart question. 2 minus, and they have asked B10 H14. Okay, this is question number 17, and you see the similarity. Question number 17 is fixed for Borane Chemistry. Correct? So this one is question number 17 in 2022. You will find it out. Okay, so now you have to solve it. Only they have asked the structure type of these two respectively. Okay, 4 options they have given. You can see in the screen the 4 options, and then but you have to solve this, right? I think now you no need to solve it by seeing itself. You can say it, right? This is B and H and 2 minus. Closo. Simply you will say here it will be B N H N 4 minus. What is this? Nido. See the option, which one is correct respectively. So you have to find it out, closo and nido, right? So closo and nido is option number A. So option number A is your correct answer. So this is 2022. That's all, right? Now I'll take 2021. So in 2021, they have asked isolable structures. Is there any other question is also there in this? Okay. No, we will solve this. Okay. 2021. Okay, question number 31. Question number 31, it is MSQ. Correct? Question number 31, MSQ. The correct statement about the species are, is or are, okay. First, they have given option number A. They have given CPMO, okay, CO3 and are isoelectronic, okay, are isoelectronic. First option is this, are isoelectronic. Now start solving it, okay. Now you know that isoelectronic, how to find it out. CP is cyclopentadienyl, okay. Cyclopentadienyl means it is it will contribute 5 electron. So here it is 5 electron. It is molybdenum. Just see molybdenum where it will come, okay. Just see where molybdenum will come. For that you have to write it. You should know the periodic table very well, then only you can solve these things. Concept you will know, okay, in later part. Concept you will know in your entire life, but the main thing, the driving license, okay, for chemistry is your periodic table. So go through with the periodic table and see how to access that periodic table, but don't memorize it, correct? Just do practice. So here we will write scandium, titanium, vanadium, chromium, manganese. Okay, now you see it will fall under chromium. So chromium and then molybdenum, then tungsten. If you are going to manganese, it will be technetium and rhenium, right? So this molybdenum is coming in chromium. So it is 21, 22, 23, 24. If metal in +2 state, they will be D1, D2, D3, D4. Okay, D4 if metal is in +2 state. So if I'll remove that oxidation state +2 and I'll say that it is in 0 oxidation state, so molybdenum will have total 6 valence electron. Okay, write it down 6. That's why I'm telling all the D block elements, just read it through. Metal in +2 oxidation state, you won't like get any wrong way. Okay, you will just find the correct electrons number if you are following these things. Metal in +2 state, right? So now 5 plus 6, and now each carbonyl is contributing 2 electrons, so total 6 electron is here. So how much it is coming? 6, 6, 12 and 5, 17 electron. This is isolable with 7 electron system, right? Now we'll come here. It will be 5. Again, this tungsten is a 6, and then carbonyl is also 6. So it is like, while solving this problem, you will get a smile, right, in your JAM paper also. So it is 6, 6, 12 and 5, 17 electron. See, both are isolable. So it is isoelectronic, correct? A option is correct. Now coming to the B, option B, what they have given, option B, CH2 minus and NH2 are isolable and isoelectronic. Okay, isolable and isoelectronic. Okay, so now you have to see how many valence electron are there. 4 plus 2 hydrogen and 1 negative charge. So negative you have to add it. So how much? 4, 2 and 1, 7 electron. Here we will see 5 plus 2, 7 electron. This is also correct. Okay, these are isolable and isoelectronic, correct? Now option number C, we will see it. So A and B we got, it is correct. Now option number C, you also try solving it, right? You have the question in the screen, so you also try to solve it. Option number C, it is BH and CH. By looking at whatever they have written, it is wrong only. Okay, this won't be your option. Iso-global and isoelectronic. Oh, whatever is there, let's see. This is 3 plus 1, so 4 electron. Here it is 4 plus 1, it is 5 electron. So these are not isolable. Okay, these are not isolable. So this option is wrong. Now option number D, we will see what they have asked. CH3 and MnCO5 are isolable. Okay, now just find it out whether it's isolable or not. This is 4 plus 3. How much? 7 electron it is coming. Now for manganese, how much it is coming? Let's see. Manganese is, again you write it down. Scandium, titanium, vanadium, chromium, manganese. Just see, metal in +2 state, D1, D2, D3, D4, D5. Now manganese in zero oxidation state, total 7 electron will be there. So 7 plus 5 into 2, 10. So how much it is coming? 17 electron. I told you, while solving you will get the smile, right? So 7 electron is isolable with 17 electron. Already we know here, right? We have written this place the isolable electron. So 7 electron is isolable with 17 electron. So D is also correct. So A, B and D. Option A, B and D is your correct option. This is MSQ type of question. Okay. So in this paper, in 2021 we don't have any further. Now we will go into the 2020, right? Okay. So as I told you, the question number also they have copied. Let's see. You remember in 2022 the question number was question number 17. Here also in 2020 the question number is 17. And they have asked the case type structure adopted by boron hydride. Okay, they are asking just B5H11. Okay, and then asking what will be the structure. 4 options. See in the screen, you can see the options: closo, nido, hypo, arachno. Whether I have to solve this or you are going to solve this. Okay, let's see. B5H5. How many proton we have to release for getting 5? So 6 proton we have to release. So here it will be 6 minus. So if it is B and H and 6 minus, what it should be? B and H and 2 minus is closo, 4 minus is nido, 6 minus is arachno. Okay, you can here you can find the skeletal electron pair also, right? How much electron skeletal electron pair will be there? N plus 3, right? N plus 3 means 5 plus 3 8 electron pair will be there. Means total number of electron it will be 16 electron, right? If they are asking that what is the skeletal electron pair in this case, so you can easily write it down, right? Whatever they are asking now, whatever concept I have given, that much is enough to solve this type of question, boron chemistry, correct? So now this also answer like arachno is option D. So your correct option will be option D. So this also 2020 is also over. Now coming to the 2019, let's see what question we have in 2019. Number of vertices in an icosahedral closoborane. Okay, number of vertices they have asked. It is question number 47. It's a numerical type question. Okay, NAT. It has asked in 2019. So what they have asked? Number of vertices in icosahedral. They have mentioned along with the icosahedral, they have mentioned icosahedral closo because they know that students are not revising nowadays. So put everything in a question. So just they have to copy and paste it. So this is only copy and pasting, right? So icosahedral means that the number of vertices should be 12, right? We know that already we have written the 12. Geometry will be icosahedral. Example will be B12, H12, 2 minus. 12, H12, 2 minus, right? So this is icosahedral. So likewise you have to solve all the questions, whatever is there. But don't solve it PYQ beyond like 2019, okay, like 2018, 2017, no use of solving those questions. So 22, 21, 20, 19, this much is enough, okay. But main thing is your concept should be clear, right? So then whatever question they will ask, you will easily solve it. So these are the things, okay. This is for only this IIT-JAM 23, okay, 2023. If you're willing to join for 2024 IIT-JAM, so week after the exam, that will be I guess on 21st, I guess 20th or 21st. Okay, whatever there is there, Monday, okay, not on 14th February, it is on next Monday, okay. We are going to start a new batch for 1 year program for IIT-JAM, both Hindi medium and English medium. So whatever you like, you can join on those GChem classes app. Otherwise my classes will be here every day, but it is not that much in detail because in app recording is not taking that much data and that much space, but in YouTube it is taking much data and much space. So I'm having some type of limitation here. So but in app it is unlimited. So whatever live classes will be taken in app, it will be like the course duration, whatever you will have for next JAM exam, right, till 2024, it will be persist till then. Okay, and then you will have weekly test, you will have unit wise test, you will have half unit, like once you will complete the half syllabus, you will have one test, and then you will have full length test. So this test will be there. So and the examination pattern and question, how it is arranged in this app, it is like how the JAM platform is there, no, JAM system. Likewise, you can appear here. So there will be 60 questions. All the questions will be covered, like MCQ, MSQ, NET type question. And one more thing which I'm providing you, it's a WhatsApp solution, right? So directly you can ask me in WhatsApp. No need to ask in group or anywhere else. If you want to discuss, you ask in group, or else you can directly ask me through my WhatsApp number. Okay, it is already given. Okay, so that solution I'll give you. So I hope you enjoyed today's class, and likewise I'll bring one more topics for next class. Maybe it will be MO diagram, because I've seen so many MO diagram questions they are asking. Okay, what is the bond order of N2 plus? What is the bond order of O2 minus? Okay, what is the bond, like sigma bond or pi bond? How many sigma bonds are there in B2 molecule, or how many pi bonds are there in B2 molecule? How many sigma bonds there in C2 molecule? So these are the questions which they are going to ask. So I'm going to deal with the hot topics again for molecular orbital, where you will be master in molecular orbital, and whatever question they are going to ask in next, you will easily solve it. So kindly support me, subscribe me, and like, and try, please share it to with your friends, so I can make more videos. Okay, so thank you very much.